Hi friends, welcome to Mature Business Machines. Today's talk about amazing forestry cutting machines. So let's start. First one is chainsaws or powerful machines, engineered to cut trees, revolutionizing forestry, logging, and even yard maintenance. They range from handheld models for light trimming to massive mechanized equipment used in commercial forestry. Chainsaws operate on either gas engines, electric motors, or even battery packs, giving users options based on their specific needs and work environments. The core functionality of chainsaws is based on a sharp, rotating chain that runs along a guide bar, using sharp teeth designed to cut through wood efficiently. The speed and power behind these tools allow them to cut through even the densest types of wood with relative ease, which is crucial for tasks ranging from felling large trees to cutting firewood. The invention of the chainsaw has roots in 19th century surgical tools, with the earliest chainsaw-like devices being used for medical bone cutting. However, in the 1920s, the chainsaw was adapted for use in forestry, with German inventors Andreas Stihl and Emil Lerp credited for pioneering modern chainsaws. Their innovations allowed for portable, powered saws that drastically reduced the labor required in logging, transforming it from a multi-man operation to one that a single person could handle. Early chainsaws were large, cumbersome, and typically required two operators. But advancements in engineering, particularly after World War II, led to the development of lighter and more efficient chainsaws that a single person could operate, making them more accessible to both professionals and hobbyists. Gas-powered chainsaws became popular due to their portability and raw power, making them ideal for heavy-duty forestry. Gasoline engines provide a high power-to-weight ratio, enabling the chainsaw to cut through large trees and thick logs swiftly. However, the power of gas chainsaws comes with a drawback: emissions and noise pollution, which can be significant. With increasing environmental awareness, electric and battery-operated chainsaws have gained popularity. These models are quieter, require less maintenance, and produce zero emissions at the point of use, making them suitable for residential areas and smaller tasks. Although battery-operated chainsaws were initially less powerful, advances in lithium-ion battery technology have made modern models increasingly competitive with gas-powered ones, especially for lighter tasks. The guide bar and chain design have also evolved, with specialized versions catering to different types of work. Chainsaws for pruning, for instance, feature shorter guide bars and low kickback chains for safer, more controlled cuts. Meanwhile, felling chainsaws used for cutting down large trees have longer guide bars and more aggressive chains designed for rapid, deep cuts. Chains can also be customized depending on the wood's density, with hard or soft wood requiring different chain types and sharpening techniques. Safety remains a crucial aspect of chainsaw design. Modern chainsaws incorporate features like chain brakes, which stop the chain almost instantly if a kickback occurs, and throttle locks to prevent accidental acceleration. Personal protective equipment, PPE, is essential for safe operation, with helmets, gloves, chaps, and ear protection being standard gear for professional loggers and recommended for home users as well. In commercial logging, chainsaws are often used in combination with other heavy machinery, such as feller bunchers and skidders. Feller bunchers are large, mechanized vehicles that grab trees at their base and cut them with a rotating saw or shear, allowing for rapid and efficient logging, while chainsaws remain vital for more precise or challenging cuts. Mechanized solutions can increase productivity in large-scale operations. Chainsaws are also crucial for tree maintenance and emergency services, where precision and speed are paramount. In urban settings, arborists use chainsaws to prune, trim, and remove trees, maintaining safety in public spaces and preventing interference with power lines and property. Emergency response teams rely on chainsaws during natural disasters, such as hurricanes and wildfires, to clear debris and open access routes quickly. Maintenance is key to a chainsaw's longevity and performance. Regular sharpening of the chain, checking chain tension, and cleaning the air filters and cooling fins are essential practices. Chainsaws need lubricating oil to keep the chain running smoothly, reducing friction and preventing overheating. Many chainsaws feature automatic oilers, which dispense a steady flow of oil onto the chain during operation. But manual oiling may also be necessary for certain models or under heavy usage. Proper storage, particularly for gas-powered models, requires draining the fuel to prevent carburetor issues and storing the chainsaw in a dry, safe place. Depth look into wood-splitting machines, exploring their origins, design, and various types while also discussing technological advancements, common uses, safety considerations, and future trends. Wood-splitting machines, or log splitters, have revolutionized the traditional, labor-intensive process of chopping firewood, making it faster and far less physically demanding. Before their invention, splitting wood for heating, cooking, or construction required an axe, maul, or wedges, techniques that have been used since ancient times. The origins of mechanized log splitters trace back to the industrial era when engineers began to seek ways to automate tasks that had historically relied on manual labor. The development of steam-powered engines provided an early means of mechanical assistance, leading to the initial designs for wood-splitting machines that were more efficient than axes. Over time, these designs evolved, incorporating hydraulic power, gas, and electric engines to improve performance and usability. The goal has always been to reduce the physical strain and time associated with processing firewood, particularly in regions with long winters or for large-scale commercial use, where significant quantities of wood are needed. At its core, a wood-splitting machine operates by applying substantial force to a piece of wood to split it along its grain. The simplest machines use hydraulic pressure generated by a piston to push the wood against a fixed wedge, creating a split with high efficiency. Most commercial log splitters range from 10 to 30 tons of splitting force, although models capable of higher force exist for industrial use. Hydraulic splitters dominate the market due to their power and ease of use. Hydraulic power systems convert mechanical energy into hydraulic energy, which applies immense force in a controlled, precise way. This type of power makes it possible to split large logs that would otherwise be impossible to handle manually. However, pneumatic and kinetic models also exist, with each type offering unique advantages. Pneumatic splitters, for instance, rely on compressed air and are generally lighter and more portable, although they typically generate less force than hydraulic models. Kinetic splitters, by contrast, store energy in a flywheel and release it quickly to split the log, offering much faster cycle times compared to hydraulics. Each type of splitter has applications depending on the wood type, user needs, and job scale, making them versatile across various contexts, from small homesteads to large logging operations. The popularity of wood-splitting machines grew with the widespread adoption of wood-burning stoves and fireplaces in the 20th century. As heating with wood became more common in rural and colder areas, demand for efficient wood processing tools increased. Log splitters allowed homeowners to prepare large volumes of firewood quickly, ensuring a steady supply of fuel throughout the winter months. Similarly, industries that relied on wood products, such as pulp and paper or construction, benefited from log splitters, as they reduced the labor and time required to prepare materials. Modern log splitters are available in a variety of designs, each suited to different needs. For example, small electric models are ideal for homeowners, providing adequate power for moderate use without the noise or fumes associated with gas engines. These models are convenient and easy to operate, often with a simple push-button start and minimal maintenance requirements. Larger gas-powered splitters, however, offer the power needed for heavy-duty work, particularly useful for individuals processing hardwood or high volumes of wood. Over the years, technological advancements have improved log splitter efficiency, safety, and user experience. Today's machines often include safety features such as two-handed controls to prevent accidents, automatic return systems, and guards to protect the operator from flying debris. Manufacturers have also focused on making splitters more ergonomic and user-friendly, reducing the physical strain on operators by incorporating adjustable log tables and lift systems for handling heavy logs. Additionally, many modern splitters come with transport wheels or can be mounted on trailers, making them easy to move to different job sites. Innovations such as electric start mechanisms, faster cycle times, and increased force capacity have made these machines more accessible and effective for a range of users, from DIY enthusiasts to professional loggers. One of the recent trends in wood-splitting technology is the development of electric and battery-powered models, which offer a quieter and more environmentally friendly alternative to gas-powered machines. These models produce no emissions, making them suitable for indoor or close proximity use, and they require less maintenance. As battery technology improves, electric log splitters are likely to become even modern chainsaw machines. The chainsaw, a tool now synonymous with efficiency in forestry, logging, and various industries, has a fascinating evolution and technological journey. Originally conceived to ease the arduous task of cutting wood manually, the chainsaw has transformed into a powerful, portable machine with wide-ranging applications. Modern chainsaws benefit from advanced materials, cutting-edge safety features, and sophisticated designs that have made them indispensable to professionals and hobbyists alike. The first concepts of a chainsaw-like device date back to the 18th century, with surgeons inventing chain mechanisms to perform precise cuts on bones during surgeries. While crude in comparison to today's technology, these early designs laid the groundwork for a device that could make quick work of hard materials. The concept of a chainsaw specifically for forestry didn't come into widespread use until the 1920s and 1930s, with the introduction of gasoline-powered models by companies like Steyr and Dolmar. These early machines were large, heavy, and required 2 people to operate, but they revolutionized logging, making it more efficient and less labor-intensive. The 1950s brought about a wave of innovations that allowed chainsaws to become more compact and manageable. Improvements in gasoline engines, the development of lighter materials like magnesium and aluminum. Modern chainsaws operate through a high-speed rotating chain with cutting teeth that move along a guide bar. This cutting chain, driven by either a gasoline engine or an electric motor, is designed to slice through wood by chipping away at the surface, creating sawdust and moving it out of the cutting area. In gasoline-powered chainsaws, a 2-stroke engine provides the energy to turn the chain, while battery-powered and electric chainsaws rely on rechargeable lithium-ion batteries or a power cord. The chain's movement speed, combined with its razor-sharp teeth, allows the chainsaw to cut through hardwoods and softwoods alike with minimal effort. Safety has always been a paramount concern with chainsaws, given the risks of injury associated with their powerful, exposed chains. Modern chainsaws incorporate several advanced safety features, including chain brakes, handguards, and anti-kickback designs. The chain brake is one of the most crucial, as it automatically stops the chain if the chainsaw experiences a sudden jolt, commonly known as kickback, which occurs when the nose of the guide bar contacts an object and causes the machine to fly back toward the operator. Anti-vibration systems have also been implemented, reducing fatigue and improving control, especially during prolonged use. Personal protective equipment, PPE, such as chainsaw chaps, gloves, and helmets with face shields, further enhances safety by providing a barrier between the user and potential hazards. One of the biggest advancements in recent years has been the rise of battery-powered chainsaws. Unlike traditional gasoline models, battery-powered chainsaws are quieter, produce no direct emissions, and are more user-friendly, as they don't require fuel mixing or frequent maintenance. Lithium-ion battery technology has significantly improved the runtime and power of these saws, allowing them to compete with gasoline-powered chainsaws in terms of performance for light to moderate cutting tasks. This development has made chainsaws more accessible to homeowners and hobbyists who may use them for pruning, yard cleanup, or light landscaping without needing the power and noise of a gasoline engine. Chainsaws have found utility in a surprising array of fields. Beyond traditional logging and forestry, they are indispensable in arboriculture, helping arborists safely prune, shape, and remove trees in urban areas. Chainsaws are also essential in rescue operations, allowing firefighters and emergency responders to clear debris quickly, access trapped individuals, and cut through building materials during a crisis. Artists and sculptors have embraced chainsaws as tools for carving intricate designs into wood, ice, and even stone. This practice, known as chainsaw carving, has grown into a respected art form, with competitions and exhibitions worldwide showcasing the creative possibilities of this versatile machine. Wood crushers is integral to wood processing industries. Work by reducing bulky pieces of wood into smaller, more manageable forms suitable for various applications, like biomass fuel, particleboard, or animal bedding, using different crushing mechanisms and design features that improve efficiency and output quality. Modern wood crushers typically consist of a high-speed rotating drum fitted with sharp blades or hammers that shreds wood by applying intense mechanical force, transforming branches, logs, or wood waste into chips or sawdust. The process starts with the feed inlet, where raw wood material is introduced into the machine, either manually or via conveyors in more advanced setups that allow for continuous operation, maximizing throughput and minimizing downtime. Once inside, the wood material is subjected to a sequence of high-energy impacts from rapidly moving blades, often made from hardened steel, to resist wear and maintain sharpness over prolonged use. These blades can be arranged in multiple configurations depending on the crusher type, which includes hammer mills, disc chippers, and drum chippers, each suited for different wood types and output specifications. Drum chippers are commonly used for larger wood pieces due to their robust cutting power, while disc chippers excel at producing uniform, smaller chips suitable for industries that demand high consistency. Additionally, hammer mills work effectively for creating fine particles, often used in making wood pellets or animal bedding. In wood crushers, the fineness of the output material is influenced by factors such as the blade size, spacing, and speed, as well as the presence of a screen or grate at the output, which restricts particle size by only allowing materials of a certain dimension to pass through. This level of control over particle size is crucial for industries like biomass energy production, where consistent chip size is necessary for efficient combustion. Modern wood crushers are often powered by high-horsepower electric motors, though some portable models use diesel engines, enabling them to operate in remote areas. Advancements in automation have allowed wood crushers to integrate sensors and programmable controls that monitor machine performance, detect blockages, and adjust the speed or force of the blades accordingly, reducing operator intervention and increasing safety. Furthermore, dust extraction systems are often incorporated into wood crushers to control the large amounts of dust generated during crushing, improving air quality, and reducing the risk of respiratory hazards for operators. This dust can be collected and reused in other applications, enhancing the machine's eco-friendliness by minimizing waste. Additionally, hydraulic systems are frequently used to simplify maintenance, allowing operators to easily access components for blade replacement or adjustments without extensive disassembly. Given their versatility, wood crushers are employed across various industries, from sawmills that need to manage wood waste to biomass plants that require a steady supply of wood chips for fuel. In the future, innovations in blade materials and machine automation are expected to increase the efficiency of wood crushers further, potentially integrating AI-driven systems to optimize the crushing process based on the specific properties of the wood being processed. The modern wood chipper has evolved significantly, transforming the labor-intensive task of breaking down wood into a mechanized, efficient process crucial for industries such as forestry, landscaping, agriculture, and waste management. Originally conceived as a simpler, manual tool, the wood chipper now combines advanced engineering with safety enhancements and environmental considerations to deliver high output in a shorter amount of time, while also minimizing operator risk. Today's wood chippers are engineered to reduce branches, logs, and other wood materials into small chips or mulch, offering a range of applications from energy production to landscaping. The central mechanism involves a powerful rotating drum or disc equipped with cutting blades that slice through wood. Typically, these machines operate by feeding wood into the chipper's in-feed hopper, where it is gripped by rollers and pulled toward the blades. This basic process is streamlined by specific design features that help maximize efficiency while reducing wear and tear on the components. To ensure smooth feeding, modern wood chippers use hydraulic systems that drive the feed rollers, adjusting the feeding speed according to the thickness and density of the wood. These hydraulic-driven feed systems help prevent clogging and offer a safer, controlled environment for handling dense or uneven wood. A key component in modern wood chippers is the cutter mechanism, which has seen significant advancement in design and durability. There are two main types of cutter systems in wood chippers: disc chippers and drum chippers. Disc chippers use a large steel disc with embedded blades to chip wood as it is fed in, rotating at high speeds to produce small, uniform chips. Drum chippers, on the other hand, use a cylindrical drum that rotates to cut wood and are particularly popular for processing larger volumes. Each system has its advantages, with disc chippers being known for their precision in producing uniform chip sizes, making them ideal for applications like paper production, where consistency is key. Drum chippers, due to their robust design, are preferred for larger forestry operations, where high volumes of wood need to be processed quickly. A notable innovation in wood chipping technology is the integration of computerized controls, which allow for real-time monitoring and adjustments. These systems can manage variables such as engine speed, feed rate, and blade sharpness, optimizing the chipping process and ensuring consistent output quality. Such technology not only improves the quality and consistency of the chips produced, but also extends the lifespan of the chipper by reducing unnecessary wear. Operators can also use these systems to monitor safety features, with automatic shutoffs and overload protections that activate in the event of a jam or irregularity. This automation reduces the need for manual intervention, allowing operators to focus more on material handling and throughput rather than maintenance. Powering wood chippers is another area that has seen development, with the choice of electric versus diesel engines reflecting the different needs of users. Diesel engines are favored for their ability to provide high power output, making them suitable for heavy-duty, outdoor chipping in remote locations where electric power may be unavailable. These engines are also engineered to be fuel efficient, often meeting emission standards while delivering robust performance. In contrast, electric wood chippers are becoming popular in settings where noise, emissions, and operational costs need to be minimized, such as in urban areas or smaller landscaping operations. Electric models are quieter, which makes them suitable for residential use and indoor applications. For safety, modern wood chippers include several built-in protections. Kickback, which occurs when wood is ejected from the machine, has long been a hazard in chipping operations. To address this, many machines are equipped with extended in-feed chutes and safety bars, which allow the operator to control the chipper without getting too close to the blades. Additionally, emergency stop buttons and safety switches are placed strategically, allowing operators to halt the machine instantly if needed. Sensors on some chippers also detect the presence of foreign objects, automatically stopping the machine to prevent damage to the blades and potential hazards to the operator. These safety measures are complemented by operator training programs that stress the importance of protective gear, such as gloves, eye protection, and hearing protection, as well as safe handling practices. Blade maintenance is another critical aspect of the wood chipping process, as dull blades not only slow down operations, but also increase the risk of kickback and poor quality chips. Most industrial wood chippers are designed for easy access to blades, for sharpening or replacement, with some models offering self-sharpening mechanisms. Regular blade maintenance ensures the machine operates at peak efficiency and reduces the risk of clogging, a common problem when blades become worn. In some advanced models, blade monitoring systems provide feedback on sharpness, alerting operators when maintenance is due, thus preventing unscheduled downtime and extending the longevity of the equipment. Chipped wood serves multiple purposes across industries, from landscaping and gardening to energy production. In landscaping, wood chips are used as mulch to retain soil moisture, prevent weed growth, and improve aesthetics. In energy production, they serve as biomass fuel for heating systems and power plants. The demand for biomass as an alternative energy source has spurred the development of specialized chippers designed to produce specific chip sizes and quality. For example, high-grade biomass fuel requires consistent chip size and low moisture content, which necessitates precise control over the chipping process. Modern chippers are thus calibrated to produce chips that meet these specifications, contributing to a more sustainable energy production method that repurposes wood waste. The environmental impact of wood chipping has also influenced machine design and operation. Many wood chippers now come with dust and particulate control systems, which capture fine particles generated during chipping, preventing them from polluting the air. Diesel engines and chippers are being replaced or modified to comply with strict emission standards, reducing their carbon footprint. Furthermore, by repurposing wood waste into usable products like mulch, biofuel, and compost, wood chipping contributes to waste reduction and supports a circular economy. Chippers are also increasingly used in forest management practices to reduce fire risk by clearing underbrush and deadwood that can fuel wildfires. Portability has become a key feature, particularly for mobile wood chipping services. Towable and self-propelled wood chippers allow operators to move easily between job sites, providing flexibility in forestry and landscaping projects. Some models come with tracks or wheels, enabling them to traverse rough terrain in forests or large estates. Towable chippers can be attached to trucks, making it easy to transport them to remote areas. This mobility feature is particularly useful for tree service companies that operate in varied environments and need to adapt quickly to different site conditions. The modern wood chipper also addresses the need for noise reduction, especially when used in residential or urban areas. Manufacturers have implemented sound dampening technology that reduces the noise levels produced by the machine's engine and cutting mechanism. By lowering noise output, wood chippers are made more suitable for use near homes and businesses, where noise pollution can be a concern. This improvement makes the machines less disruptive and more acceptable to communities, expanding their use in areas where they may not have been previously feasible. Beyond the standard applications, wood chippers have found use in more specialized settings. In orchards, for instance, chippers are used to dispose of pruned branches, turning them into mulch that can be reapplied to the orchard floor, returning organic matter to the soil. In agricultural settings, chippers help manage crop residues and tree prunings, reducing the need for burning and thus lowering air pollution. For ecological restoration projects, wood chippers are employed to clear invasive plant species and to process materials that are later used in soil restoration or erosion control. While most wood chippers are stationary or semi-portable, some innovative models are fully autonomous, equipped with GPS and AI technology that allows them to navigate through forests or fields. These advanced chippers are programmed to identify and process specific types of wood or vegetation, reducing the need for human intervention and increasing operational efficiency. Autonomous chippers represent the future of forest management and land clearing, particularly in large-scale operations where labor costs and safety concerns are paramount. Despite the technical advancements in wood chippers, operator training remains essential. Each machine, regardless of how advanced, requires a skilled operator who understands its capabilities, limitations, and safety features. Training programs often cover proper feeding techniques, machine maintenance, and emergency protocols, aiming to prevent accidents and ensure a smooth chipping process. Additionally, manufacturers offer guidance on optimal operating conditions, such as avoiding wet or frozen wood, which can clog or damage the chipper. A well-trained operator can significantly enhance the machine's efficiency, ensuring maximum productivity and safety. In the field, operators encounter a variety of wood types, each requiring adjustments to chipping speed and blade sharpness. Hardwood species like oak or maple are denser and require sharper blades and slower feed rates to prevent strain on the machine. Softwoods like pine are easier to chip and can be processed at faster rates. Recognizing these distinctions is critical for achieving uniform chip sizes and preventing unnecessary wear on the machine. In some cases, operators may need to alternate between different blade types or sharpen blades more frequently when working with harder woods. Recycling wood chips back into the ecosystem can play a role in soil health and biodiversity. Mulching with wood chips enhances soil structure, conserves moisture, and provides a slow-release nutrient source for plants. This use of wood chips has ecological benefits, particularly in agriculture and horticulture, where it supports sustainable land management practices. Wood chips are also used in playground surfaces and walking trails, providing a soft, decomposable surface that reduces erosion and blends into natural surroundings. As demand for wood chips continues to grow, particularly in renewable energy and sustainable agriculture, the wood chipper industry is likely to continue evolving. The focus will remain on efficiency, safety, and environmental impact, with an emphasis on reducing emissions and waste. Innovations such as electric engines, improved dust filtration, and autonomous functionality will shape the future of wood chippers, making them even more essential in modern forestry, agriculture, and landscaping. Ultimately, the modern wood chipper represents a blend of mechanical ingenuity and environmental responsibility. Stump Removal Excavator is an innovative piece of heavy machinery specifically designed to tackle the challenging task of removing tree stumps from the ground. These excavators play a crucial role in land clearing, landscaping, and construction projects, where the presence of stubborn stumps can hinder progress and create safety hazards. The development of stump removal excavators represents a significant advancement in the field of excavation, combining power, efficiency, and precision to address the unique challenges posed by tree stumps. The operation of a stump removal excavator typically involves several components that work together seamlessly. At the forefront is the excavator's hydraulic system, which provides the necessary force to perform heavy-duty tasks. The hydraulic system is responsible for powering various attachments, such as stump grinders and augers, which are essential for breaking down and extracting tree stumps from the ground. The ability to manipulate these attachments with precision allows operators to efficiently remove stumps without damaging the surrounding landscape. One of the primary attachments used in stump removal is the stump grinder. This device is equipped with sharp, rotating blades that can grind stumps down to below ground level. The grinding process involves cutting the stump into small wood chips, which can then be removed or left to decompose in place. Stump grinders are particularly effective for larger stumps that may be difficult to extract using traditional methods. The versatility of stump grinders makes them an indispensable tool for excavators, enabling them to handle a wide range of stump sizes and types. In addition to stump grinders, many excavators are equipped with augers, which can drill deep holes into the ground to facilitate stump removal. Augers can be used to break up the soil around a stump, making it easier to uproot. The process typically involves drilling multiple holes around the stump, which weakens the root system and allows for easier extraction. This method is particularly useful in cases where stumps are deeply rooted and require more than just grinding to remove them completely. The design of stump removal excavators is also tailored to enhance their effectiveness in various terrains and environments. Many models feature tracks instead of wheels, providing better stability and traction on uneven ground. This design allows operators to maneuver the excavator easily across different surfaces, from soft soil to rocky terrain. The stability offered by tracked excavators is essential when working on steep slopes or in tight spaces, where traditional wheeled equipment might struggle. Moreover, stump removal excavators often incorporate advanced technologies to improve operational efficiency and safety. For instance, some models are equipped with GPS and remote sensing technology, enabling operators to precisely locate stumps and assess their size and depth. This information can be crucial for planning the most effective removal strategy. Furthermore, safety features such as operator cabins with protective screens help minimize the risk of injury from flying debris during the stump removal process. The versatility of stump removal excavators extends beyond just stump extraction. These machines can also be used for a variety of landscaping and construction tasks, making them a valuable asset for contractors and landscapers alike. For example, they can assist in grading land, digging trenches, and clearing brush, thereby maximizing their utility on job sites. This multifunctionality reduces the need for multiple pieces of equipment, streamlining operations and cutting costs. In the context of environmental sustainability, stump removal excavators can play a positive role. By efficiently removing tree stumps, they help prepare land for new growth and development while minimizing soil disturbance. The wood chips generated from grinding stumps can also be repurposed as mulch or compost, promoting a more sustainable approach to land management. This aspect is increasingly important as more landowners and contractors seek environmentally friendly solutions for their projects. The market for stump removal excavators has seen significant growth in recent years, driven by the increasing demand for land clearing services. As urban areas expand and infrastructure projects become more common, the need for efficient stump removal has become more pronounced. Additionally, the rise of DIY landscaping projects has led homeowners to seek access to professional-grade equipment for their own stump removal needs. As a result, many equipment rental companies have started to offer stump removal excavators, making them more accessible to a broader audience. Thanks for watching. Please leave a comment and share this video with your friends, so don't forget to subscribe to this channel. Meet in a new video.